Now, if you're going to be working in any type of Microsoft administration services these days, there are some fundamental principles that are very important that you understand. So what I want to do is I want to get into some of the foundations of understanding things like Microsoft domains, understanding some of the networking technologies, RAS and VPNs and virtualization, and also we're going to talk about the cloud services and how all that fits into this. But it's important to kind of start from the beginning so you can understand where things have been, understand where things are going, and you have to consider the fact that the world is transitioning now more into a cloud-oriented environment. But in the past, everything was managed on-prem or on-premise, and we got to talk about this transition and how things were and how things are now and where Microsoft is going. So to start with, we go back in time to the 1950s, 1960s. They had mainframes, these gigantic computers that would take up like entire rooms. They used vacuum tubes. And then as we moved into the 1970s, something miraculous happened. They created what was known as an IC, an integrated circuit, which allowed basically binary math to be processed through little chips. And this is where personal computing became popular. So in the 1980s, personal computers started coming out. I'm going to draw this little symbol here to represent a computer. And I tell you what, I'm going to create another little symbol here to kind of represent a bunch of computers. So in the 1980s, companies started buying PCs and personal computers, and they started showing up in people's offices, and eventually, they were networking them together and all of that. And so this is where things really get started. Now, of course, in those days, one of the problems was we lived in what was called a peer-to-peer network. So what would happen is these computers you could network these computers together with various technologies, but there was no centralization, meaning each computer was equal. There was no computer that controls all the other computers. A network admin would have to, if they wanted to make changes, they'd have to sit down at each and every computer to make those changes or get users to help them, which was always a nightmare. And so that didn't, it worked, but it didn't work very efficiently. All right. Now, as we moved into the 1990s, there was a company that was gaining ground called Novell, and they had a product called NetWare, which was the idea of that was to use a server that would help manage machines and also allow people to share files easier. Whereas in a peer-to-peer network back originally, these machines would have to share files with each other and people would have to know each other's passwords. It just didn't work very well. Well, eventually with the creation of the file server concept, you had a more powerful machine that you could share files on and all that. And eventually Novell even came out with the idea of a server that could manage other machines. Now this is kind of where Microsoft comes in. Microsoft created their product called NT, and they created this concept of a domain controller, which is a special type of server that can manage these other servers. Now, fast forward, they came out with what was known as a domain, but fast forward to the year 2000, Microsoft releases their newest domain technology, and they call it Active Directory. And Active Directory domains were represented by a triangle. All right, and a domain controller was a server essentially that had a database on it, and that database was the Active Directory database. So let's just kind of fix that here. This little cylinder looking thing I'm going to make here is going to represent my Active Directory database. So AD. All right. And this is what we still call to this day. We call it ADDS, Active Directory Domain Services. And usually if you hear that term, Active Directory Domain Services, it means it's an on-premise domain. Although there is a version of this that can be hosted in the cloud known as Azure Active Directory Domain Services. I'm not getting into that right now. So anyway, you would always want to have more than one domain controller. The reason you want to have more than one domain controller is because the same reason you have more than one of any type of server, really. One reason being to break up the disbursement of load. These machines will authenticate with these domain controllers, and the more machines you got, you don't want all of that just going to one domain controller, right? The other consideration is redundancy. If you only have one and that server goes down, well, you're in trouble, right? So we want to have multiple. The other thing about domain controllers that are interesting is that they replicate. So, for example, I'm going to make a little smiley face guy here, and this little smiley face guy is going to represent my user. So we create a user account on a domain controller. Now, the interesting thing about user accounts, or the interesting thing really about domain controllers, is that they replicate. So everything you do on one will replicate over to the other. So if I create a user account on that first one, well, replication is going to occur between both of them. And so this little arrow thing I'm going to make here is going to represent replication. So domain controllers replicate. That means that this user could log on to any one of these thousands machines, and it's going to authenticate with the domain controller. All right. The authentication protocol that is used is the protocol known as Kerberos. All right. Kerberos is the authentication protocol. What is a protocol? It's like a language, basically. Okay. Now there was an older protocol that it also supported called NTLM. That was for legacy, for older prior to the year 2000 machines. Now that protocol allowed us to have encrypted passwords and all that, and authenticate securely and all that fun stuff. The other thing is Active Directory uses a language known as the Directory Service Language. And that language was called LDAP, Lightweight Directory Access Protocol. Now all that is, again, this is all decades old at this point. At the time when it came out, it was cutting edge, but it is a bit dated nowadays. But it still works, and it's still pretty secure, though there are some considerations on security that I'm not going to explain right now. Now the other thing that's important about Active Directory is that all machines have to have a name. And the name must be, of course, associated with an IP address and all of that. And so there is a service that we use it on the internet all the time, called DNS, Domain Name Service. Our domain must have a name. Usually when you name your domain, you would name it after your company, and a lot of people even name their domains based on their web presence. So for example, my domain might be called examlabpractice.com. That's my company, my web presence. And I'm going to need to have a server in my domain that can associate the names and IP addresses together. So that server is called a DNS server. DNS, Domain Name System Server. And that server will also have to have a little database on it. And that database will be our DNS database. Okay. So we'll just draw another little cylinder, and what I'm going to do is I'm going to highlight this, border it with red, and then I'm going to color code the database red, which means that this database, the DNS database, is associated with that name. Now what happens is our machines, clients, domain controllers, we also might even have, let's draw a file server over here. Pretty common that we have file servers in our environment. Okay. All of these machines would register with our DNS. All right, and this allows for the centralization of name resolution, meaning they register their IP addresses into this database, and then now anytime a machine needs to find another machine, it can query DNS. So for example, these machines all have to authenticate by your domain controllers. They can query DNS and say, hey, DNS, do you know what the address is of one of my domain controllers so I can authenticate? And DNS can reply back and say, yeah, here is the information. At that point, the client can go and authenticate. So it works very efficiently. Now, all of this together, this idea of domain controllers, this triangle you see here, this provides centralization. So we moved away from peer-to-peer networking back in the day where every machine was kind of its own boss and there was no centralized way of managing things, to now we are working in a centralized environment. These domain controllers help us centralize. This DNS service helps us centralize. So we now have some central control over things. One of the great things about our domain controllers too is we have these wonderful things called GPOs, Group Policy Objects. A group policy object is this object that you can create that has all these settings, parameters, any type of attribute you want to configure or change on machines, you can do it through a GPO. So for example, if your boss walks up to you and says, hey, I want you to force the firewalls to be turned on all these machines. I want to make sure that the antivirus is always up to date. I want you to disable some of the wallpaper feature. I don't want people putting crazy wallpapers on their machine. So I mean, the sky's the limit. There are literally thousands of things you can do inside of a GPO. But what happens is that GPO can instruct these machines to turn things on and turn things off. GPOs also replicate. So when you create a GPO on a domain controller, it replicates over to the other domain controller. So it doesn't matter which machines, authenticate with which domain controller. All right. So these GPOs can be deployed out to these machines, and this is how you turn things on, turn things off. You could even deploy software with that if you wanted to. So it was very, very powerful. A very, very powerful system for managing everything. All right. Of course, let's throw the internet into the mix here. Let's say that this little cloud is going to represent the the internet, and let's talk about a little bit about how that sort of fits into the picture. Let me just clean it up here with the mighty stroke of my paintbrush. I will clean up the internet. All right. All right, so then we have the internet, right? So maybe we've got an internet connection that's coming in here. All right, and of course you don't want to just leave your internal network exposed, so your company would generally have a firewall, right? And we'll just put that firewall right here. And so now we have a secure way for traffic to flow out to the internet, and the only things that can come in would be things that we send out, and we could allow things through that firewall if we want to. Now, this is a traditional domain. This is the way we've done things for 20 years, all right? And in this next little section, I want to talk about expansion on all of this and where things have gone with things like RAS and all that, and VPN and virtualization. So that'll wrap this little section up, and we'll move on to the next. I now want to talk about some concepts that are also sort of the foundation of how we've done things over the years. It's important to understand how we've done things over the years so we can understand how things are now. So looking back, we have an Active Directory domain, ADDS as it's called, Active Directory Domain Services, which uses the LDAP, Lightweight Directory Access Protocol, which uses Kerberos for authentication, or for the legacy back in the 90s devices that used NTLM, New Technology LAN Manager, which isn't all very new these days, but even Kerberos is pretty old considering, we've been using it for decades, and I think actually the protocol even came out back in the 1980s. So we got some data technologies, but the technologies have been updated, a lot of them over the years, to be secure, so you can still feel comfortable using those. But let's talk about some different scenarios now. The first thing I want to look at is the scenario of what happens when we have a user who is not at the office. So this person is working from home. Working from home is a lot more popular nowadays than it has been in the past, so it's very common. And this person needs the ability perhaps to be able to connect in and access services that are inside. Okay, and we've got a file server, but ultimately you probably are aware that in the past it was always this mindset of do it yourself, host your own server. So your companies might have a file server, but then they might also have a they might have a SQL database server that users need to access. Let's create that SQL. All right. Maybe Microsoft Exchange. That was email, right? Microsoft Exchange was used for email, and then maybe even like SharePoint was very popular by Microsoft on premise. So here you've got these these 4 servers providing a service to our devices, and you've got users working from home and everything else needing to get access to those. Let me just kind of move those a little bit over here. Make a little bit of room here. And I'm going to shrink those down just a little bit as well. All right. So this user who is working from home needs to access these services, but the person is not, not around. Well, let me tell you what you shouldn't do. You shouldn't just open up all the ports on the firewall and allow this person in to get access to these devices unsecurely. In fact, in the 90s, a lot of companies did that. The very first company I ever worked for, back in the 90s, they didn't really have a firewall, so you literally could share out you had a public address, and you could connect to it from home. It was really scary when I think about it. Even in the 90s, that was scary, but nowadays it's incredibly scary. Why is it scary? Because you got these people out there that want to do things that they shouldn't do, and get access to companies' data and try to do damage and ransom and all of that, ransomware and all that. And who are these people? Well, we generally call them hackers, right? So let me draw a little hacker. This little box here is going to represent my hacker. All right, and let's make this hacker look like he's up to no good. All right, I'm gonna give him let's give him like a devil horns, some devil horns here, and maybe he's in a bad mood. I'm gonna give him a frowny face, and give him some fangs, and maybe the fangs are dripping blood okay, no, I'm just kidding. Sorry, sometimes I get carried away. All right, but anyway, that's going to be my hacker. All right, goofy looking little hacker person. All right, and so we don't want this hacker spying on my user. We don't want this hacker getting access to resources inside. So how do we get around that? Well, usually the way we would do that is you would use a VPN, a virtual private network. So the way you would do that is you could purchase what was called a VPN concentrator, and basically it's a device that allows secure connections in. But in the Microsoft world, we actually had a type of server we could set up called a RAS server, or also known as an RAS server because it stood for Routing and Remote Access Services. But anyway, remote access services is the idea here, and with that we have support for VPN. Now what does that do? This allows this thing called a VPN tunnel to be created, which means that you have this encrypted communications that goes through to that RAS server, and then from there that RAS server allows you to access other resources securely. This hacker will not be able to see the traffic that's flowing through because it's all encrypted. The only thing the hacker would be able to see is that it was going up to this firewall, and that would be it. Wouldn't be able to see what the traffic said. So this is how we would definitely help secure things. Now, the other thing that I want to talk to you about here is what happens when a company needs to have a service that is exposed to the internet. For example, let's say that your company is going to host their own web server, okay? So you set up a web server. All right, maybe this is going to be www.examlabpractice.com or whatever, and people from the internet need to be able to get to it anonymously. Well, how are you going to do that? Where are you going to put that web server? Are you going to put it internally inside the domain like you see here? And the reason that's scary is because you would have to open up port 443, port 80, which is the HTTP ports, to allow traffic to get in, which means not only could somebody out there on the internet anonymously get into this web server, but technically so could a hacker. And if a hacker was ever to gain access over this website by hacking it, then something called pivoting could occur, where a hacker could actually gain access to these other services that are on your network. And so that's where things are really scary. So you definitely won't want to host it internally most of the time, although there was a way to do something called a reverse proxy. I won't get into that right now. But we would probably want to put this outside, right? So we want to put it out here. But there's something else that's a problem on that. If you put it outside that firewall, you don't have to worry about people getting allowing traffic to come in. But the scary thing about that is the fact that this poor web server is now completely exposed to the internet, so with no protection. So the way around that usually is people would get another firewall. So you'd have two firewalls. This first firewall would be called the internal connected firewall, and then this firewall here would be called the external connected firewall. Now this little network between that, we would call that a DMZ, demilitarized zone, or now the more popular term is perimeter network. Okay, so DMZ, perimeter network are basically the same thing. All right. And so now what you would do is you would only open the ports like port 80, 443, 53 for DNS if you put DNS in there, whatever ports there that you need, and now traffic would be able to get to this web server. Okay, and so even if a hacker somehow hacks this web server, you're not going to allow traffic to pass through this firewall and get to these resources. The only traffic that you might allow would be VPN. Okay, and there's a bunch of authentication and all that has to happen to make that work. All right, so that's the idea of remote access and VPNs in a nutshell for you, as well as the concept of DMZ and the perimeter network idea. Now, the final thing I want to look at with you in this video is the idea of virtualization. So I talked about how in the past it was always the mindset was we got to host everything ourselves. We got to have our own little data center. We got to have our we got to have our own servers, file server, SQL, Exchange, SharePoint, all that, and it's all got to be hosted by us. And that's the way things have always been done. All right. Now, then what you'll find is as time went on, a company called VMware came out with a way of expanding on virtualization. Just so you know, virtualization is not a new term. Virtualization has been around for a very long time. In fact, the term hypervisor is essentially the software that lets us emulate hardware. And if you can emulate hardware, you can also store software on that emulated hardware. That's the idea of virtualization. That term hypervisor has been around since the 1970s. The idea of even mainframes dividing up processing time and doing shared computing was a form of virtualization. So this is not a new concept, but VMware, they expanded on this idea, and the thing that they did that really pushed the envelope on all this was that, hey, you don't necessarily need 4 different servers. And here's the other thing. Here's the other crazy thing. If you wanted redundancy for those 4 servers, you'd really need 8 servers, right? You could do clustering those together. So you'd have 8 servers to provide redundancy for those. But with virtualization, I can set up a hypervisor server, 1 server, and virtualize those other servers. Now, in the Microsoft world, we call that Hyper-V. That is the software that does this, Hyper-V, hypervisor. Microsoft's not the one that came up with that. VMware is not the first to ever come up with that. VMware was the biggest contributor to this concept, though, so I do have to give them credit where credit is due. All right, now the other beautiful thing, though, about this is you get a really, really powerful machine. You virtualize your machines on those. You get these things called checkpoints in Microsoft. They used to be called snapshots, and a lot of other companies still call them snapshots, where you can make changes without the worry of breaking anything because you can revert back to before the change was made. The other thing that's wonderful about using virtualization is if I want to have complete redundancy, I don't have to have 8 servers. I could literally, purchase another server and have a copy of the virtual machines on that other server. Now I've only got 2 servers as opposed to having to have a total of 8 servers. Okay, so this is a very powerful feature capability that kind of started everything. Another thing that we got, and this is kind of where you start thinking about cloud computing, is with virtualization comes the term elasticity, which basically means that each of these machines can be given a certain amount of RAM processing power. But here's what's interesting about that. If one of the servers isn't using all of the available RAM that it's been given, it can share it with other servers. So for example, this file server has been given more RAM than it needs, and then SQL needs that RAM. The file server can give up some of that RAM over to SQL. And when SQL's done using that extra memory, it can release it back to everybody. It's basically a pool type scenario where it gets released into a pool of RAM and pool of CPU, and they can grow and shrink as they need. And that's a small way of sort of on-premise way of looking at elasticity. Of course, when you get into cloud computing, you'll learn that can expand across multiple machines across the board in these big data centers, but not to get into that just yet here. But that's the idea. Hopefully that now helps you with understanding that concept of what virtualization is. And with that is really where, cloud computing started to come into play, which I'm not explaining in this video. But hopefully now you have a much better understanding of the concept of the RAS, VPN, as well the DMZ concepts and virtualization. And now in this next section, we'll start getting into the concept of cloud services. Now, with the creation of virtualization, this got companies thinking, if we can emulate hardware, we can create these virtual machines, and we can store software on there. We can have operating systems running on that emulated hardware, the operating systems being called guest operating systems. We could technically host these virtual machines for companies for a price as a service. So the idea being, hey, you pay us a fee each month and we'll host your virtual servers, and you don't have to deal with all the headaches of hosting your own data center on premise, and the power that's needed to do that, and the air conditioning that's needed to do that, all the hardware that's needed to do that, as well as the knowledge of how all the hardware works. So this is essentially what a cloud company brings to the table. So various companies like Google and IBM and Microsoft and Apple and all these companies, a lot of them already had tons of data centers, these big massive warehouses all over the world that they could support it. Some of these companies, such as Microsoft and IBM and Amazon, and Amazon being one of the biggest and first, decided to open this up to the public for a fee and allow you to host your services in their data centers. So this is where cloud computing really comes into place. This big cloud here is going to represent cloud computing, mainly the Microsoft cloud computing. And of course, it's all connected to the internet with incredibly fast, high-speed internet connections, fiber connections, and all of that. So there's some terminology or some acronyms I want to talk a little bit about real fast here as we get into this. First off, in cloud computing, there is an acronym we call IaaS. That stands for Infrastructure as a Service. Okay? Infrastructure as a service means that a provider is hosting all of the hardware infrastructure for you, and then they are going to provide you with a way for you to interact with that hardware and utilize their hardware as a service. All right, and this, of course, is where Azure comes into play, Microsoft Azure. Now, you might pronounce that word different. People have different ways of saying Azure. Some people call it Azure. Some people call it Azure. Some people call it, I've even heard it called Azure before, Azure. There's various names for it. In fact, years ago when I was first learning Azure, I decided I wanted to make sure I was pronouncing this correctly. So I was like, I'm going to go to watch the developers. So I started watching videos of the developers, the people who created Azure, and I figured I would determine. The very first video I ever watched, the guy was pronouncing the word Azure, so that's how I say it. But what I further learned is that the Microsoft developers don't agree on how to say it either. Some of them say Azure, some of them call it Azure, some of them call it Azure. So anyway, tomato, tomato, pronounce it however you want to pronounce it, okay? But Azure is Microsoft's main IaaS system. What this is Microsoft is going to host, they've got all these data centers all over the world, and they're going to host their hardware so that you can host on top of their hardware your virtual machines or whatever it is. So you can host virtual machines. Microsoft will also allow you to have access to what are called virtual appliances, like virtual firewalls, also virtual load balancing software, because you can get access to what are called VNets, This is virtual networking, so you can create these virtual networks based on TCP/IP that are running your, in their cloud service with virtual machines on it, and then you can put a virtual firewall. So you can almost like recreate what you're seeing here in an on-premise environment. You can recreate that in the cloud. They also provide virtual storage, so you can store data and backup data out there. They support database hosting, all of that. That's all part of IaaS. Now with IaaS, the model for that, for the most part, is you pay for what you use. So there's an algorithm that looks at how much memory, how much processing power, how much storage that's being used, and then you get a fee each month for what you're using. The good news is they do have a calculator that kind of helps you forecast this. And you can even set alarms to let you know if you're approaching a certain budget that you've got on cost. There's a lot of things out there to help you do that. But that's the idea. You pay for what you use. Okay, now there is another couple of terms I want to mention as well. This next term is called Platform as a Service, and then there's a third term called Software as a Service. So Platform as a Service, PaaS, and Software as a Service. Platform as a Service and software. Let me explain software as a service first, because it's pretty easy to visualize, and then I'll explain platform as a service. So the idea of software as a service is basically they have applications that can be hosted in the cloud service, apps, if you will. These apps are 100% ready to use, ready for you to take advantage of. All you got to do is use those applications. Okay. For example, Microsoft has what's called Office for the web, or it used to be called Office Online. So that's like Microsoft Word, Excel, PowerPoint. You can run it from within your web browser. All you got to do is just jump right in and use it. So from an admin standpoint, all we have to do is assign the users that are allowed to use that, and they can go use it, and it's available to them 100%. All they got to do is start using it. There's not really a lot of administration for us. Now, what is Platform as a Service? Well, Platform as a Service is a system in which the majority of the configuration is done for us, but we still have some admin configuration we have to do to use it. For example, with virtual machines, this is 100% IaaS. A virtual machine you can put whatever operating system on there, but you're responsible for the operating system. You're responsible for the software that goes on it. You as an admin have to manage all that. Okay. With Platform as a Service, virtual machines are set up in the background that you don't have any control over. They've already put the operating system on there. They've already put the software on there. You don't have any control over any of that. But there's still some administration you have to do in order to control it. For example, Microsoft has a directory service called Azure AD. Now, this is a big deal. This is probably one of the biggest deals of the things I've gone over so far in this cloud. Azure Active Directory is what we call a platform as a service. It is a directory service that is sort of the cloud version of what you have here called ADDS. So, now I remember when I first heard about Azure Active Directory, I thought, oh, well, this is just like you're just hosting virtual domain controllers in the cloud. No, they have completely redone the concepts of Active Directory. It is completely redone with all new web-based programming languages. It does not use any of the dated stuff like LDAP and Kerberos and all that. It uses industry standard authentication protocols in order to support all the latest and greatest features and capabilities in the cloud. Okay? And so these are where users, passwords, all of that stuff is going to be managed in the cloud. But it starts out with almost nothing in it. So it's ready to use, but you as an admin have to start creating users and all of that. Now you might say, well, wait a minute, what if I want to use my on-premise users in the cloud? Well, stand by, I'll explain that in a second. Anyway, Azure AD is a platform as a service. So is, here's another one, Exchange Online. Microsoft has Exchange Online. That is actually both a platform as a service and a software as a service, in that the admin side of it is the platform as a service, but the user side is the software as a service. Same thing for SharePoint Online. Microsoft has SharePoint Online as well. Same idea there. All right. And then you've got Microsoft Teams. That's the admin side of that is a platform as a service, but the user side of that is a software as a service. There is OneDrive for Business. That's a cloud storage that we have access to that allows users to store their data out there in the cloud. There is a product called Intune, which is Microsoft's MDM product. MDM, it's also MAM product, so it's both. Mobile device management, that allows us to manage devices. This is one of the most powerful things we have available to us. This is what sort of is replacing the concept of GPOs. This is going to allow us to manage our device settings. Not only can we manage on-premise devices, but we can manage mobile devices. GPOs can only manage devices for Windows. With Intune, we can manage Windows, Android, iOS, iPadOS, macOS, all that stuff. With the help of Intune, we can manage the settings and restrictions. We can deploy software. This is a very, very powerful product, okay, that we have available to us. It even has a thing called Autopilot, which will allow us to reconfigure Windows machines and all of that. So very, very powerful stuff that we have available to us. All right. Now, I will tell you that Azure has, Azure definitely has some of the, it has some platform as a service technologies and some software as a services technologies, but the main type of system that Microsoft has created for platform as a service and software as a service is called Microsoft 365. Okay, Microsoft 365. All right, which I forgot to add to my display here. We actually do have apps that are called the Microsoft 365 apps. All right, which formerly they would call them Office 365 apps. They're now, starting to call them Microsoft 365 apps. But the Microsoft 365 services is a cloud service that basically sits on top of Azure. So you have Azure in the background of all this, and the Microsoft 365 sitting on top of it. All right, you can't have a Microsoft 365 account or tenant that doesn't also have Azure. Azure is in the background no matter what. And the other thing to be aware of is both of these share Azure AD. So you'll notice that there are web portals for creating users and things through Microsoft 365 or creating users through Azure. It all ties back to Azure AD. You're going to see the same users no matter what. So these two things are glued together basically. Okay, they're glued together. Now on Microsoft 365 with PaaS and SaaS and all that, you're not really going to be hosting virtual machines, but you're going to be working with these services. Let's just kind of color code some of this real quick. All right. Now again, I do want to add that Azure does have PaaS and SaaS services that I'm not getting into right now, but it's mainly an IaaS based service. That's its main focus. Microsoft 365 is strictly PaaS related and software as a service, SaaS related. It doesn't really have any virtual machines or any of that, though it can interact with them. Okay, so if I was to sort of draw a circle around some of these, all of this stuff you see here would be Azure related, and then all of this stuff you see right here would be the Microsoft 365 related. Now, they both share Azure AD, so I'm going to put a purple circle around that. Red and blue make purple. All right, and so they all link to that. Okay, and so that is how Microsoft handles those concepts. The other thing about With Azure, you're paying for the CPU, RAM, storage you use. With Microsoft 365, it's all based on licenses. So you purchase these subscriptions that have a certain amount of licenses, and you issue these licenses out to your users, and your users can take advantage of these various features. Okay. One more thing I want to explain here, and that is, what about the issue of what if we want to use our on-premise users to access resources in Azure? Well, Microsoft has a solution for that. They actually have a type of server that you can set up, and the server is called an Azure AD Connect server. Azure AD Connect. Now, what does this do? An Azure AD Connect server, this is a synchronization-based system, and what it will do is it will allow my on-premise users to be synchronized out to Azure AD. Now, it does not allow Azure AD users to be synced in, only out. But it will allow user passwords and all of that to be synced in. So if a user is logging on to Azure AD and they change their password out in the cloud, it does have the ability to synchronize that password back in. But the beauty of this is by going this route, if you have this on-premise environment, you can achieve what we call SSO. What is SSO? Single sign-on. The idea of single sign-on with all of this is my user can sit down at their on-premise computer, they can log on, and it's going to log them on both in the cloud as well, it's going to log them on-premise as well as in the cloud at the same time. All right, and they can access resources out there. The other thing I'll tell you is that Microsoft has moved into a way to where you could technically not even have a domain nowadays. You don't necessarily have to have a domain. In fact, it pains me to say this as a consultant because, I have fed my family for, 2 decades by using Active Directory, both teaching it as well as, consulting on it. But I'll be honest, Microsoft is now moving in a direction to where domains are not even needed anymore. They're now making it possible to where everything can be managed through your cloud service and domains are not needed. But if you're a company that's already got a domain and all this is still in place and all of that, then this Azure AD Connect server is going to be the thing that's going to help you. Okay? All right. Well, hopefully this has now helped you have a better understanding. This was really just a fundamentals video to help you understand the cloud service, the concepts of it, and I hope that this has been helpful to you. Let's talk about capacity and planning and speed requirements when it comes to Azure Virtual Desktop. Now, there's an extremely great document here on Microsoft Learn that outlines the important facts that you're going to want to know here. All right, it's called Remote Desktop Protocol Bandwidth Requirements. You can find this document very easily just by going to Google or Bing and just searching for the Azure Virtual Desktop Bandwidth Requirements. If you do a quick search on that, you'll see it's the very first article that shows up. All right, so this article outlines at first when you look at it, you're like, oh, well, this is just remote desktop. Well, what you want to know is that with Azure Virtual Desktop, you're going to be using the remote desktop protocol. So if you think about it, if you've got, let's say, 100 clients in your on-premise network that are going to be using Azure Virtual Desktop, they're going to be using remote desktop protocol to remote into those virtual machines. Okay, and so RDP, the bandwidth requirements, is what you really want to focus on. All right, and they even talk about it here. If you read through this article, you'll see it's talking about Azure Virtual Desktop and stuff like that here. But here's the key elements to understand. First off, when you connect in to a Azure Virtual Desktop with Remote Desktop, there are various things that are going to take up bandwidth. All right, for one, you've got what are called heartbeats. A heartbeat is just keeping the session going between the client and the virtual desktop. And they tell you it's about 20 bytes every 5 seconds. You've also got input where you have the client session notes the amount of data is based on the user activity. It's usually less than 100 bytes from most operations. So when they're clicking around and things like that, usually less than 100 bytes, they tell you. Of course, there's file transfers. That's going to depend on if you're doing file transfers, how much bandwidth that's going to use between your on-premise network and the Azure Virtual Desktop. Printing obviously can take up some, some of that as well. There's also other scenarios to consider if you were using voice, video, some type of real-time communication, or if you're maybe streaming in 4K. All right, but they have a really helpful capability here that will kind of help you hone in on this. And they talk about estimating the bandwidth based on graphics. So you can imagine that graphics, anything graphical, is going to consume the majority of the bandwidth in most cases. All right, and they tell you that, like with 1080p desktop image, in an uncompressed form is 8 megabytes in size. Displaying this image on the locally connected monitor with a modest screen refresh rate of 30 hertz requires bandwidth of about 237 megabytes. Okay, so yeah, but it utilizes compression and all of that to try to optimize this. And there is ways to even optimize it further with optimizing frame rate, screen content classification, so it focuses on certain types of bitmap images and things like that. Context-specific codecs for compression, image encoding, client-side caching. So, is it really going to use the full 237 megabytes? No, that's the beauty of all of this. All right, it's gonna go extremely fast, and they have this nice little table here that you can look at. If you have a single monitor, let's say 1920 by 1080, which is a very popular resolution, utilizing the graphics mode, the default graphics mode, and the H.264. This gets into real-time transferring of graphics, essentially. So idle, 0.3K, something like Microsoft Word, they tell you between 100 and 150K if you're using the H.264 AVC mode. It's going to be more, all right? So you could essentially double it, all right? You'll see it kind of doubles. Microsoft Excel, the average. PowerPoint, the average. Just browsing the web, there's your average there, okay? And you'll also notice, though, that when it comes to things like the web, the H.264 AVC 444 mode is very optimized for that. All right, so you're going to notice that it's taking less bandwidth there. All right, RDP uses dynamic bandwidth allocation as well, so it's designed to adjust, go up and down based on what's needed, and doing what's called throttling and all that. There's also some stuff to quality of service. I'm not going to get into this video, but you can do that as well to help adjust the bandwidth. So the thing you really got to do when you're planning all this is you got to think about, well, first off, how many clients do I have? How many clients are going to be using this, day to day? How many hours a day on average? And then what's the average things they're using this for? Okay, is it Word? Is it Excel? Is it PowerPoint? Or is it a custom type of application? Perhaps you work for a bank, and this is a piece of banking software. Maybe you work for medical in the medical industry, and it's a medical type of software. On average, you could kind of you would want to be thinking more along the lines of Microsoft Word and Excel if you were doing something along those lines. All right. Of course, there is ways to also test this out and get a better measurement, and I'm not going to get into that in this video, but remember, this is just talking about planning. So the starting point is definitely what you want to do is look at this article. All right, take a look at especially this table, and then be thinking about how many clients I've got. All right, what's their day-to-day activity, and then you can add this up on a per second basis. So the average client, how much megabytes of data are they going to be taking on an average of per second? And then of course you have to be thinking about your internet connection at that point, right? All right. So that is definitely what you want to think about in regards to capacity planning and all that when it comes to the network side of Azure Virtual Desktop. The next thing we have to be thinking about when we're going to utilize Azure Virtual Desktop is our network connectivity with Azure itself, and making sure that we're choosing the best region in Azure that's going to meet our needs and give us the best performance. Or really, I guess more importantly, what you need to be thinking about is, where are your clients located at? Okay. If your clients are located in a certain area of the world or the country, they're going to have better connectivity with Azure in certain regions. Remember that Azure is broken up into regions. In these different regions, these regions are areas of the world where Microsoft has data centers, and they have extremely high bandwidth going into these data centers. And so what you got to do is think about, where are my clients at? Ideally, you would be on site at that location where your clients are at, or in that area at least, and then check to see what your latency is with Azure. So there's a great little website you can go to. If you do a quick Google or Bing search on Azure Virtual Desktop Experience Estimator, you can find this right here. Here is the link right here as well if you wanted to type it in, but you can do a quick search for it, probably quicker than typing this in. And then it's going to give you this little estimation tool here, and this estimation tool will tell you, based on where you are right now, what your internet connection is. It's going to tell you what the round trip time in milliseconds is from where you are. So based on my internet connection, it's telling me here it's West Central US. But keep in mind, if you're connected to a VPN, then it can be a little bit misleading, because the VPN can be, telling you that you're somewhere else. For example, I know for a fact that I'm actually on the East Coast of the United States. So in reality, without a VPN or something, this is going to be my best latency, East US. But ultimately, if you're not connected through a VPN or something, then you want to be looking at the Azure region. So the second thing I want to show you is, if you go to this website called azurespeed.com, this is another great little, they have a few different tools here for testing latency and stuff like that with Azure. The only thing I don't like about this little website is it has these advertisements on it, but if you just close out of the advertisements, it's a handy little website. So I can see right here, Azure latency test. If I'm in the United States, I could click here, like East US, for example, and I can get a latency connection in real time right now with East US, okay? And so you can see what the latency is there. All right. Same thing if you wanted to check some of these other regions like West US 2, I could throw that one in there. Now I've got two of these going. You can see that what my latency is looking like there. All right. And of course there's some other tests. I'm not going to get into all these other tests right now, but some other little tests there you can try out as well, which is really nice. So those are the two main considerations I would be thinking about in regards to your connectivity with Azure directly, and helping you choose the correct region that you're going to be hosting your Azure Virtual Desktops in. Now, when it comes to connectivity with the Azure Virtual Desktop, there is some prerequisites to keep in mind. All right, you can find this document simply by just doing a search for prerequisites for Azure Virtual Desktop in Google or Bing. This is the document. And if we go directly to the network section here, the key things I want to get across to you in this short little video is that the Azure Virtual Desktop is going to operate off of, they tell you transmission control is going to happen over 443 is the default. However, the RDP short path, which I'm not getting into short path right now, will use what's called managed networks and supports public networks that establish UDP connections, which is a even faster transport. But again, not getting into short path just yet. All right. Now, the other thing to understand here is that when you're doing Azure Virtual Desktop, you will need to set up a virtual network for your session host to be a part of. The session host is going to be on this virtual network in which you're going to be utilizing to have connectivity with your virtual desktop machines as people are going to be connecting into it. All right. So the session host is what's controlling the connectivity with your Azure Virtual Desktops. Now, again, don't worry. If you're like, I don't really understand all the concepts here of session host, stay tuned. All right. Don't worry about that. All right. Just be aware that you will have to have a virtual network that's set up in Azure. Virtual networks don't cost any money when you set up a VNet in Azure, but this is all stuff to come, all right? Keep in mind, I'm going to be doing lots of demonstrations. Right now, we're just trying to understand certain foundational requirements here, all right? They also tell you here to make sure that your virtual network can connect to your domain controllers and relevant DNS servers. If you're going to tie this all back to an on-premise domain, you got to make sure that you have connectivity there, all right? More to come on all this, all right? So you're going to support port 443. Now, the other important thing to remember is this right here, required URL list. Okay, you got to make sure that your firewall on-premise is not blocking certain URLs. As a consultant, I can tell you I've ran into this before. I worked for a company one time, and one of the issues they had was connectivity for all this, because their firewall blocked everything going out except approved sites. So this was a very high security network that I was on in terms of like what they would allow their people to connect to. So they had an issue with that where they didn't have connectivity. So they had to add outbound rules on their firewall services to allow these URLs. So here are the URLs. And don't worry, you don't need to memorize all these URLs, but I would be aware of the fact that there are certain key URLs and IP addresses and all that. You got to make sure you're not blocking when it comes to utilizing the Azure Virtual Desktop services. Okay, so here they are. Again, you can get there by going to the prerequisites and then clicking on this link, or you could just go to Google or Bing and just search for required URLs for Azure Virtual Desktop, and you can find this link that way as well. All right, so definitely a good thing to do. They also tell you can validate that your session host VMs can connect to these URLs by running this required URLs check tool. So this is another nice little feature. You can download this little tool and you can run this little tool. So that's something to keep in mind as well. That can be a great little tool for helping you test to make sure that you have all the requirements that are needed to establish connectivity between on-premise and Azure for Azure Virtual Desktop. In this video, I want to help you understand the concepts of RDP short path as well as quality of service involving the Azure Virtual Desktop. Then we're going to jump in and see how we can enable this on machines. All right. So the first thing is I want to show you a diagram here from Microsoft that kind of helps you visualize what's going on. And I want to talk about the various elements that are involved here, and then we'll talk about what RDP short path and quality of service is going to do for us. All right. So if you look here, you have in Azure, you have the virtual desktop infrastructure. So this is your VDI environment that would be hosting your Azure Virtual Desktop. Essentially, what we used to use in an on-premise network for this was just a standard VDI. We would have remote desktop servers and all that. With Azure, they're going to host the Azure Virtual Desktop infrastructure for you, so you're not having to host like on-premise servers to manage any of this. So there's different elements involved here. First, they provide a remote desktop gateway, RD gateway, which is the thing that you're essentially connecting to from the internet. So when clients connect into the virtual desktop, they will establish first a connection with this RD gateway, which will of course have a public address associated with it and all that. Another thing that happens is they provide the RD broker. So if you have multiple virtual machines, you have what's called a session host, which is your virtual machine somebody's going to connect into, and you have what's known as a host pool as well, meaning you have multiple Azure virtual desktops that are available, and they could all just be the same image over and over and over. So you have multiple instances of this that can be connected. So what happens is your RD broker load balances those connections, okay, and establishes a RDP based connection with your client. Another option, of course, for clients connecting to this session would be using the RD web capabilities, which allows you to connect to a remote desktop session using a web browser. Okay, now for the other thing to be aware of here is the authentication must occur. So when a user is communicating with a Azure Virtual Desktop, there's two different methods for authentication. One being they can authenticate directly with Azure Active Directory, which is sort of the way Microsoft wants you to do it these days. Another option is, of course, if you've got an on-premise Active Directory, like they're showing here, Active Directory Domain Services, then you can set up what's known as Azure AD Connect, where it synchronizes your user accounts and all that out to Azure Active Directory. You can still support that authentication with Azure Active Directory, but it will authenticate back with your on-premise Active Directory services. Now, let's talk about the dilemma, the problem. Now, the original issue with this is a client would connect in to this RD broker, and then the RD gateway, and the RD gateway would then go to the broker, and the broker would load balance you up to whichever VM pool you're supposed to go to, or whichever Azure Virtual Desktop. Now, you can also set up unique virtual machines for your individual users if you don't want to have just a pool of the same virtual machines, but I'm not going to get into that in this video. All right. The issue, of course, is there's latency involved there. Having to go through all these different components in order to establish a connection with your Azure Virtual Machine, your Azure Virtual Desktop, is going to slow things down. So what Microsoft did originally is they made it where if your company had a direct connection to Azure, and there's two main ways you could do that. So this is your on-premise device. If that on-premise device could connect directly into Azure using either a VPN, like a site-to-site VPN, or Express Route. Now, if you know Azure, those are your two primary ways that your on-premise network could establish a direct connection with Azure. Using a site-to-site VPN, which is Virtual Private Network, that being one way, and then the other being Express Route, which is actually a dedicated wide area network connection that you would establish through a telecommunications provider. And those would be your ways. Now, if you did that, then Microsoft would allow you to utilize ShortPath. ShortPath means you still go through all of this to establish the initial connection, but once that initial connection is established, ShortPath takes over, and you're now directly connecting to the virtual machine using RDP ShortPath over UDP. Now, for a long time, you could only do this if you had that dedicated connection to Azure, either the VPN method or ExpressRoute. But I'm proud to say, excited to say, that Microsoft has finally started supporting this over the public internet. Meaning, you don't have to have your company does not have to have a direct VPN into Azure or ExpressRoute. Now, ShortPath can work without it. So you can now connect from a client into your initial Azure gateway or RD gateway. It'll work with the broker, establish that initial connection, and once that's all set up, at that point, ShortPath takes over, and your client is now directly talking to the VM. It's not having to travel through that path, and you're going to get much better performance. Another thing that ShortPath brings to the table is QoS. QoS is quality of service. Quality of service is going to allow me to have rules in place on my devices to give higher priority to the traffic through RDP. So if you have on-premise devices, okay, these on-premise devices, and you got equipment like network switches and all that support quality of service, your devices can tag the traffic, their packets, with quality of service to basically say, hey, these are high priority. This remote desktop traffic is high priority, okay? And so that information can be tagged, and you also have the ability to have the session host can tag it as well in order to make sure that all network equipment, the equipment in Azure, the equipment on your on-premise network, if you support quality of service, you can have your machines tag it, all right? And of course, I'm going to show you some ways we can go about doing that. All right. So now what I want to do is I want to jump in and see how we can implement short path and quality of service, how we would turn these features on in regards to Azure Virtual Desktop. So here I am on my NYC DC1 domain controller, and what we want to do is we would like to deploy a group policy out that is going to enable this feature on all of my machines. So if I've got a scenario where I've got a bunch of clients in a Microsoft domain that are on premise, and I want them to be able to support this RDP short path feature, I want to deploy a policy out that can do this. Now, if your machines are not part of a domain, then that's fine. You can actually enable this locally. But if they are part of the domain, if you had 100 machines, you obviously don't want to sit down at each individual machine and turn this on. So we'd want to use a policy for that. Now, the first thing I want to show you is Microsoft has a little article that walks you through step by step on how to do this. If I pull up my web browser, just do a quick search on Google or Bing for configure RDP short path. They walk you through how to do this. Okay. Now, the first thing to be aware of is if you try to locate the policy in a GPO that does this, it's not there because it's not built into Active Directory. You have to add what is called an administrative template to do it. And let me show you what I mean. So if I go right now to Server Manager, go to Tools, and I go to Group Policy Management, and don't forget you can always get to Server Manager by hitting Start and looking for it. Here's Server Manager. So then if I go to Tools, Group Policy Management, here's the Group Policy Management console. Expand my domain and all that. Go here to Group Policy Objects. Just create a GPO. I'm just going to call this RDP Short Path. Alright. So we'll turn that on. Alright. And we're going to go ahead and click OK. And I'm going to edit that GPO. And the location where the policy should be would be under Computer Configuration Policies, Administrative Templates. So I go there. Okay, and then we're going to go under Windows Components. All right, then we're going to scroll down to Remote Desktop Services and expand that out. And then if we look at the Remote Desktop Session Host, this is where the policy would be. But as you can see, it's not there. It doesn't exist. So what we've got to do is we go back up. I'm going to close out of that and go back over to this article. They tell you got to download the administrative template. So if we click to download this, and I'm going to open up the little cab file, and it's going to have a zip file. I'm then going to go into the zip file, and I'm going to extract the zip file to my C drive. Okay. So it's extracted to my C drive. I'm going to go to my C drive now. And there's the zip file. I'm going to go and open that up, and I'm going to go into ENUS, all right, in my case, and I'm going to copy this ADML file. I'm going to copy this ADML file to the C drive Windows folder, and I'm going to put it in the policy definitions folder here, and then the ENUS. So we're going to paste it in to that folder. All right, now that's just a language file, so we're going to jump back over to the C drive. We're going to go into the zip file again and scroll down to the bottom, and this is the ADMX, this is the XML file that's going to be needed. So we're going to copy that, go back to the C drive, go back to Windows, okay, policy definitions. Let's locate that. There it is. All right, and then we're going to paste it in here with the other ADMX files. All right, so now we've got the ADMX file added, and we should also have the language file added, the ADML file. All right, so all that should be good to go. Yep, there it is, right there. And so we'll minimize that. We'll go back into Group Policy Management. We're going to edit the RDP short path GPO that I created. I'm going to expand under Computer Configurations Policy, Administrative Templates, Windows Components. All right, we'll scroll down and locate Remote Desktop Services and then Session Host. And there you go. Azure Virtual Desktop policies are now officially showing up. Now, the actual policy that we care about to turn this on is going to be this policy right here, Enable RDP Short Path for Managed Networks. We're going to double click on that, enable that, and the default port is 3390, which is what is recommended that you use. All right, so make sure you don't have any firewalls or anything like that that's like blocking that port outbound. All right, so we'll click OK. Next thing we would do is we'd actually drag and drop this over our wherever we want this to apply. If I want to apply to every machine in the domain, I'm just going to drag and drop it over the domain. Remember that with group policies, it can take 90 to 120 minutes before it will take effect on every machine. Okay, so that's how we can get the RDP short path turned on with the help of a group policy. Now, you could do this locally on a machine as well by opening up the local policies on a machine, but this is how you do it through the domain. Now, keep in mind, I actually don't have any like virtual machine host right now in Azure Virtual Desktop. We haven't added that yet. So we just set this up on our domain controller, and when we start adding Azure Virtual Desktop's host pools, then what will happen is when they join the domain, they will automatically get the short path policies deployed to them. Now, let me show you a little bit about the quality of service side of this. Let's jump over to our domain controller. And we're going to edit our RDP short path GPO. You could create a separate GPO for this, but I'm just going to use the one I've already created. I'm going to right click that and click edit. All right, I'm now going to go under computer configuration policies and then Windows settings. All right, and then I'm going to go right here where it says policy based QoS. From there, I'm going to right click that and say create a new policy. All right. And now I'm just going to give it a name, so I could name the GPO or the policy, whatever I want to name it. I'm going to call this RDP QoS. All right. Now to specify the DSCP value, the DSCP value that you're going to want to use is going to be 46. All right. And then I'm not going to worry about specifying a throttle rate right now. All right. And remember that the DSCP value is the differentiated services code point. I'm not getting into like the Cisco world of QoS and all that. This is all part of the tagging that is used. So I'm going to go ahead and click next. And then as far as applications are concerned, you're going to click on only applications with the executable name. And the executable name that will be used for this will be the svchost.exe. So we're going to put in svchost.exe for that. We're going to click next, and then for the source IP addresses, destination IP addresses, we're going to leave that as a default, which is set to any, and then we're going to click next. Hey, I just wanted to jump in real quick here. I realized after I had made this video that I had made a mistake on this next little screen here. Essentially, I forgot to choose the correct protocol. You're going to see on the screen it's going to say TCP, but it really should say UDP. Now, I will also say that quality of service can use a TCP as a backup, but UDP is the preferred method of TCP. If you don't believe me on all that, just go out there and do your own research, and you'll see there is some documentation that tells you that TCP can still work, but UDP is definitely the default and the preferred way to do it. So again, this is something you have to go back and fix if you do like what I did. All right, and do this whole thing. You can always go back and fix this, but just make sure that if you're doing this, that you select where it says TCP on this next screen. You want to switch that to UDP, and from there, it's asking about from any source port, destination port. So from any source port, we're going to say from this source port number or range, we're going to set that to the 3390, which is, of course, what the RDP short path and all that uses. All right. We're not going to have to worry about this for destination ports, so we'll leave that alone. We're now going to click finish, and there you go. At that point, we've enabled the quality service tagging that's needed. And we've now officially got the quality of service policy set up, and same rules going to apply for that. Essentially, eventually it's going to get deployed out to our machines. Granted, we got to have our virtual desktops joined to the domain in order for that to take effect. Okay, Now, if you did not have your machines joined to the domain, it is possible to edit them locally. In fact, you'll learn how to create an image where you could just enable this locally once on the image and then deploy your host pool for Azure Virtual Desktop that way. Okay. But hopefully this video has helped you understand the concepts now of utilizing the RDP short path as well as the quality of services. One of the most common things that we're going to want in an Azure Virtual Desktop environment is to support public DNS name resolution for the various services. Now, we've registered a name, in my case, called examlabpractice.live. It's a custom domain name. I've registered it. It's being hosted through GoDaddy, as you can see here. The problem is that I don't want GoDaddy controlling my DNS records. I actually want Azure to control my DNS records. Currently, if we scroll down, here I am on this GoDaddy account looking at this, you can see that this ns53.domaincontrol.com, that's a GoDaddy name server that's controlling everything. And we don't want that. We want Azure to control everything. So if we jump back over to portal.azure.com, go to the menu, go to all services, we can search for DNS. And what we want to look at is this DNS zones right here. So we're going to click on DNS zones, and we're going to click to create a DNS zone. This is basically, when they say zone, they're saying it's basically a DNS database that can be hosted in Azure. So I'm going to choose the demo RG resource group, and I'm going to put in examlabpractice.live. Okay, we're going to click review and create, and click create. So this is going to create a DNS database that will be publicly accessible from Azure. As you can see, it's done. So we're going to click go to resource. And here's the trick really to making all this work. You have got to essentially make it where Azure is managing these is the DNS registration service for the zone, meaning the name server records that you see right here is what your original registrar needs to point to, and currently that's not the case, right? Currently, if we go in here, we can see that GoDaddy is doing this. So if we click change right here in GoDaddy, all right, it's going to give me an option that says enter my own name servers advanced. So we're going to go right here, we're going to copy this first one, and we're going to paste that in, and I'm going to take away the dot at the end. We're going to copy the second one and paste that in. Actually, we can just get rid of the dot there and just paste in this third one and put a 3 there. Paste in the fourth one, take away the dot, put a 4 there. I think that is all correct here. Yeah, 1, 2, 3, 4. And then in my case, one's com, net, org, and info. So we'll fix that too. Right, so com, net, org, and info. Com, net, org, and info. All right. So now we're just going to go ahead and click save. All right, and it does warn you. This is, hey, changing name server is risky. Could potentially lead to your website disappearing from public view, etc., etc. So yes, I consent. Hit continue. All right, so we'll give this a little bit of time here. This does take some time before it takes effect. And I would say give it at least 15 minutes, bare minimum, before moving forward. Now, there is a way we can test to make sure that our DNS is public live here and hosted through Azure. What we can do, I'm just going to right-click right here where it says All Services and open up a new tab. And then I'm going to jump over to that new tab. And we're going to look at the public address of our domain controller here. So we're going to go to the menu button, and I'm going to go to Virtual Machines. And I have NYC-DC1 that I've set up. And I can see the public IP address of that. So I'm going to copy that and go back over here to this other tab. And I'm going to add a record. And I'm going to paste in NYC-DC1. All right. A record, put in the address, click OK.
Now, keep in mind, in the real world, I'm not a big fan of making a DC public accessible from the internet. This is just for lab purposes so that we can test things out. Now, I'll also warn you that when you create that record, it may take a few minutes before you can test this out.
Now, the final piece of the puzzle here that's going to be very important for setting up our Azure Virtual Desktop is if we are going to allow our Azure Virtual Desktops to join our domain. Now, keep in mind, you don't have to let your Azure Virtual Desktops join your domain, but if you want your Azure Virtual Desktops to join your domain, they are going to need connectivity with your domain controller's DNS service, okay? And so what we're going to do, we're going to actually go over here to look at our domain controller. We're going to go here to demo RG. We're going to click on our NYC-DC1. We're going to go to networking, and you can see the private IP address of our domain controller. And this is what we need our virtual network to point to, okay? And so what we're going to now do, if we click back on our network interface, the network interface is connected to our virtual network, this right here, AVD VNet. We're going to click on that, and then we go over here to where it says DNS. Now, I've already configured mine, but when you go here for the first time, this may be set to Azure default, provided default, and you need to set this to whatever your DNS server's address is. In my case, that's 10.0.0.4, okay? And so I need to make sure that is set, and then I'm going to hit save, all right? And then from there, the reason that's so important is when your Azure virtual machines, your virtual desktops, try to join the domain, they need to be pointing to that address to locate the domain service. Now you might say, well, why not just put that in that publicly accessible DNS zone that we've created? Well, it's not a good idea to truly put Active Directory related content in a publicly accessible DNS service, because anybody on the internet could query for that information, so that's dangerous. So this is why when it comes to just joining a domain, you want to keep that stuff private, okay? So in our case, we're going to put the private address in there, and this is going to enable our Azure Virtual Desktops to be able to see the DNS service that is running on the NYC-DC1 domain controller, all right? Okay, so that is going to be important when it's time for us to create our Azure Virtual Desktops. We want to make sure that is done. When it comes to troubleshooting and monitoring network issues involving Azure, whether you're dealing with Azure Virtual Desktop or you're dealing with just standard Azure virtual machines or the platform as a service, there are certain techniques and tools that will definitely come in handy. And I'd like to show you that right now. But right now, we don't have any kind of virtual machine or anything to play around with. So we're just going to throw a quick Windows 11 virtual machine into our Azure environment, and we're going to learn how we could troubleshoot network connectivity with it. All right. So here I am on portal.azure.com. All right. I'm going to go right here to the menu button, and I'm going to click on virtual machines. And we're going to go to create a virtual machine. All right. So we'll just drop down create. We'll click on Azure Virtual Machine. All right. And then from there, we are going to create a Windows 11 virtual machine. All right. So here we are on the create a virtual machine screen, and we're going to create a resource group. I'm just going to call this Monitor VM Demo RG4 resource group. All right, we're going to call this VM. I'm just going to call it VM1. Just keep it simple, and I'm going to put it in East US region. I'm not going to do any kind of redundancy or any of that. Now remember, the point of this video is not to go through every little setting of creating a VM. The point is just to create a VM real quick so that we can troubleshoot it. Okay, so we'll go here. We're going to go with Windows 11. So we'll go right up here, choose Windows 11 Pro, and that'll be just fine. And we'll just go, I'm just going to go with the standard size that we have here, 2 virtual CPUs, 4 gigs of RAM. And I'm going to create an admin account called ELP Admin and create a password for that. ELP Admin is short for Exam Lab Practice Admin. All right. I'm going to leave the ports and all that the way it is. It is going to create a little virtual network, and that'll help us with what we need to test, right? And from there, it's asking if I can confirm eligible Windows 10, 11 license, multi-tenant hosting rights, all of that. No, watch what happens here. So if I go and I'm just going to go standard hard disk drive. Okay, that's fine. And then we'll leave all the networking the way it is. And we'll go to management. And I'm going to have the VM shut down at 7 p.m. Eastern Time in my case. That way, if I was to forget to shut the virtual machine down, it will get shut down later. That way, it's not using up Azure credit. You always want to remember that when you're done with these, the hands-on on a lot of these, you can go and delete the resources so they don't use up your Azure credit. All right. So we'll go to monitoring. I'm going to disable the boot diagnostic monitoring. We'll click to advanced, nothing on advanced, tags, nothing on tags to do. Now watch what happens here. We're going to try to validate it, and you're going to notice that validation has failed. So why has it failed? Let's go back, scroll down, because we have to confirm. Now, even if you don't actually have a multi-tenant license for Windows 11 and 10, you can still choose this just for testing purposes. All right, so we're going to click Review and Create. All right, it should validate this time. So we'll let that happen. All right, and it did validate. So we're going to go ahead and click OK. All right, so that is now going to go through the process of creating a quick Windows 11 virtual machine that we can do some testing with. Now, the other thing I want to talk real quick about is when we are working with monitoring settings and things like that, or troubleshooting, there is something called a log analytics workspace. A log analytics workspace is going to allow me to log information about resources, including if I was going to log the information involving a virtual machine, a Azure Virtual Desktop, platforms as a service, storage, you name it. Log analytics workspaces are basically a component in Azure that's going to let me gather log data. And at that point, I can go back and peruse that log data at my convenience. So while the virtual machine is getting created, I'm going to click the menu button and go to All Services. Okay, I'm going to search for Log Analytics. All right, and then we're going to choose Log Analytics Workspace. We're going to click to create a Log Analytics Workspace. All right, as far as resource group goes, I'm going to store it in the Monitor VM Demo RG resource group, and I'm going to call it Monitor VM Resources. That's going to be what my Log Analytics Workspace will be called. And I'm going to go here and just going to switch this over to East US. We're going to click Review and Create, and we're going to click to Create. All right, at that point, it'll take a little bit of time, but it is going to create that Log Analytics Workspace. All right, and currently we're still in the process of creating our virtual machine. So I'm going to give this just a couple minutes. I'm going to pause my recording and let this finish. Now that my resources have been created, I'm ready to check those resources out. So I'm going to click here to look at my virtual machine. I'm going to click Go to Resource, and here I am on VM1. And the first thing I want to do is just connect into the VM just to make sure that everything is working. So I'm just going to click Connect, click RDP, and I'm going to download the RDP file, and I'm going to open the RDP file. Now it asks me to put my credentials in, which I already did, and I'm going to click Yes to connect. All right, so here it is connecting. I'm going to give that just a second, and then I'm going to set the screen up a little better where you can see it. There we go.
All right, and it is connecting into that Windows 11 box here. So it looks like it is successfully connecting in. So I guess one thing to consider if you're monitoring or troubleshooting any kind of a service, whether it's a standard virtual machine or Azure Virtual Desktop or whatever it may be, platform as a service, it's always good to just see if you can make that initial contact with that resource. And obviously in this case I am able to make that contact, so I am able to successfully connect in. All right, so you can see it's asking me to go through this little out-of-box experience type thing in Windows 11, and I'm not really, the point of this isn't really to get into configuring Windows 11 or any of that, but as you can see, it is connecting. I am connecting here into Windows 11, no problem. So I've got good connectivity with my virtual machine. But if we did not have good connectivity with our virtual machine, let's talk about what we would do to troubleshoot issues. All right, so let's go back into Azure. Now, one thing that gets created whenever you have a virtual network. Now, if we go back over to our click on Overview of VM1. We have a resource group called Monitor VM Demo RG. I'm going to click on that. And you can see that there's different elements that make up a virtual machine. Here's the virtual machine, but the virtual machine has different components. Number one, we have a public address that's associated with the virtual machine. Here it is right here, and that's a public address that we were able to connect into with Remote Desktop. Then we have network security groups. Network security groups are like IP filters. It's not a firewall, but it does some of the basic things that a firewall can do, which is filter IP addresses in and out. You have a virtual network adapter or network interface. Okay, that network interface is associated with our public and private address. Then we have a virtual disk that our data is stored on. Okay, and then of course this log analytics workspace I created separately. But these are the elements, these are the components that are inside of my virtual machine or my resource group. Now, the other thing to be aware of is that whenever a virtual network is created in Azure to store, to let your resources communicate on the network, something called the Network Watcher is created. The Network Watcher is a component that essentially is going to let you monitor resources. In fact, if I go to the menu button here and I click on the resource group's blade, you're going to notice that a resource group called the Network Watcher RG was created. I didn't create that. That gets created automatically whenever you have a virtual network. And one of these will get created for every region that you have a virtual network in. I only have a virtual network in East US right now, so it's created a watcher for that. It is a set of services that are able to monitor and help you troubleshoot network issues. Okay? All right. So that's the first thing to be aware of. All right. So what can I do to utilize that? Well, I can go up here to the menu button, go to All Services, and I'm just going to search for Watcher. All right. And when I search for Watcher, you're going to see the Network Watcher is a resource I can click on. All right. And the first thing that can come in handy for troubleshooting is just to visualize how Azure's virtual networking is set up. And we got this thing called topology that we can click on. All right. Now, sometimes I will warn you that sometimes when you first create your resources in Azure, sometimes the topology does not recognize everything immediately. Sometimes it can take 30 minutes to an hour, but it looks like today I got lucky. It actually does show my resources. So you can see that I have VM1. VM1 has a virtual NIC. That virtual NIC is connected to a network security group, NSG, named VM1-NSG. That's the IP filtering I was telling you about. The virtual NIC is also connected to a public IP address called VM1-IP. From there, we're connected to a virtual network called Monitor VM Demo RG VNet, and that has a subnet called Default. Okay, and the neat thing about this topology generator here is you can click on these components and go straight to them if you want. Okay, but here's what I really want to show you. I want to go over here to this IP flow verify, because these are going to be for diagnostics, monitoring, and troubleshooting. Click on IP flow verify, and it's going to let me test if there would be any blocking, any allow or block connections going on with my virtual machine. In other words, I can test to see if certain types of traffic is going to be allowed to connect to the VM or denied the ability to connect to the VM. Okay, so right now I've got VM1 resource group. This is my interface, TCP inbound. This is the private address of the VM, and let's see what happens if I was to test. Let's see what happens if I was to test port 3389. That's RDP. All right, and we'll put in the public address. Let's say we're connecting from this public address, so I could figure out what my own public address is and put that in. And we'll say 3389, and we're going to click check. All right, and so it is going to tell us if there would be any type of issue with making a connection if you were at this address and you were connecting to that address here. Now keep in mind, what they're not telling you is that you have a public IP address that's actually being associated with this 10.0.0.4. So you're actually not connecting directly from the internet to 10.0.0.4. You're connecting to a public address, which is translating to 10.0.0.4. But you can see that I would be allowed. There's not a rule that's going to deny me. I'm going to be allowed. And actually, if I click on VM1 NSG, I can go there, and you can see that there is an allow rule for RDP. Okay, so I would be allowed. All right, so let's go back and let's try port 80 from this address. All right, port 80. Doesn't matter if the address is the same. We're just kind of simulating if you're coming in from the internet. All right, and let's see what happens. All right, now the thing that you also need to remember is this is not actually sending any traffic. Your computer, that address, is not actually sending any traffic. It's just running some simulations to see if there's going to be a rule that's going to block you. And as you can see, I would be denied. Why? Well, the reason I'd be denied is because that NSG, that network security group, does not have a rule that says let port 80 connect. All right, so you end up getting this default deny rule because of what is called the NSG, the network security group. All right. Now, if I'll clarify that a little bit more. If we go back here and we look at the NSG, I just clicked forward. Okay, here's the network security group. There is not a port 80 rule. So what happens is when traffic comes in, it checks this rule first. If that rule doesn't apply, it checks that rule. That rule doesn't apply, it checks that rule. Well, ultimately, if none of those rules apply, you have a default deny rule that says deny everything. So that ends up being what happens. Okay. All right. There is an NSG diagnostics tool for testing network security groups. I'm not going to get into that right now. There's also a tool called NextHop, which is good if you've got a lot of VNets going on in your network and you've got traffic having to flow from subnet to subnet to subnet, or if you've got traffic having to flow through a firewall or something like that. You can test to see where your traffic is going next. So if 10.0.0.4, which is VM1, is trying to get to, let's say, Google's DNS server, 8.8.8.8. That's Google's DNS server, if you didn't know that. It's just an easy one to remember. We can see what the next hop is going to be. This is going to tell me if my virtual machine is having to go through like a firewall or some kind of a gateway that before it's going out to the internet. Now, in my case, I don't have any kind of firewall or gateway or anything. So ultimately, the response I should get is that it's going straight out to the internet. Okay? Because again, I don't have any of that stuff. So it should just ultimately say internet. Yep, next hop is internet. So we don't have any kind of firewall or anything. But once you start playing around with Azure firewalls and all that, and you have traffic directing through that, this is a way you can tell where your traffic is going next. All right. There's also effective security rules. This little blade here, this is involving more about NSGs and all of that. I'm not going to get into any more details on that right now. This is a VPN troubleshooting tool for troubleshooting VPN connections. Not going to get into that right now. You could also do packet capturing if you want, which is helpful. If you got something like Wireshark, you can capture packets from a VM and then see what are going on with your packets. Packets are little pieces of data, right, that are traveling across the network. There's also a connection troubleshooter tool, which is helpful, where you can see, you can actually do testing from one VM to another, or from VM to the internet, or something like that. All right. So there's some testing there you can do, but this is going to come in handy more in a situation where I've got multiple VMs trying to communicate with each other. So I'm not going to get into that a whole lot, all right now. Okay, so those are some of the helpful troubleshooting tools to keep in mind when trying to troubleshoot and monitor virtual machines. This also includes Azure Virtual Desktop and the platform as a services and all of that. But one more thing I want to look at, let's go back over to our virtual machines. We're going to click the menu button here. We're going to go to virtual machines. Okay, we're going to click on VM1. All right, and let's go to networking. All right, and here is our virtual network. So our virtual network interface. So we're going to click on our virtual network interface. All right, and we can see in our virtual network interface that we have a thing called alerts. We have something called metrics. We have diagnostic settings. There's even this thing called insights, which I'm not going to get into a lot of details just yet on that, but it gives you another little bit of a visual and kind of a quick glimpse or overview. You can also open up a ticket if something's going wrong, but again, not getting into insights a whole lot right now. Alerts, though, alerts are helpful. But before we look at alerts, let's look at metrics. So with metrics, I can see different performance metrics that are going on involving this resource. Now, of course, in my case, the resource I'm looking at right now would be this virtual NIC. All right. So I can look and see what the average bytes received are. I can see bytes sent. I can see packets received, packets sent. Okay. And look and see what the average is of that. Now you have that with your virtual NIC. You also can go over to the virtual machine itself, and there are metrics involving the whole virtual machine, not just your virtual NIC. So you can do that there as well. All right, and so you can look at see what the CPU stuff is going on. I can even see things like CPU credits remaining. That gets into your Azure credits. Data bandwidth, IOPS, there's lots of stuff here. And if you hover over these, you get a description of what they are. Because obviously there's a lot of metrics here, and keeping them all straight is sometimes difficult. But if you hover over them, you can see, the description of these metrics. All right. Now, when it comes to the VM itself, as well as your NIC, your virtual NIC, let's go back over to networking real quick. And let's click on our virtual NIC for our VM. We can also go to diagnostic settings, and we can gather log data for what's going on the machine. We can do that right here. We can say add a diagnostic settings, give it a name. Let's call this network, we'll say VNIC metrics. All right. Click all metrics, send to a log analytics workspace, and we can select our log analytics workspace, and it's going to log it there. Now, I will warn you that when you create a log analytics workspace, unfortunately, it can take up to an hour before it actually will start showing up right here. So it hasn't been an hour yet. Sometimes it can even be longer than that. I don't know why Microsoft hasn't fixed that yet, but it can take, there have been times where I have done this and it happens in the first 30 minutes, and there are times where it can take an hour. I've even had it take a couple of hours before the log analytics workspace shows up here. We do have one though, but I would be able to click it, and I would be able to click save, and at that point, what's neat about that is it'll now start logging data into that log analytics workspace. Okay, and I'll then have logging data that I can go back and peruse at my convenience. Now keep in mind, a log analytics workspace does cost money because it's using storage, but it isn't usually going to cost you very much money. It doesn't cost a lot of storage. All right. Just remember that you can always see how much credit and all that's being used with Azure. All you got to do is click the menu button and go to all services and just look at subscriptions. right here, and it'll give you a number right here when you look at it, tell you what your total cost is right now. Well, it's sometimes a little bit slow at showing that. There it is. I've only used about a penny, but I can click here on Azure subscription, and I can also go to cost analysis, and that'll show me some information involving that. But I don't want to get too deep into cost analysis, any of that. I just wanted to show you real quick how you could tell that. One more thing before we move on. I'm going to go back over to virtual machines, click on my VM, and again, I can do the same thing with my virtual machine as I did with the virtual NIC. I can go to diagnostic setting, all right, and right here I can enable monitoring if I want. Now, when you do monitoring on a VM, they do want you to have a storage account for that, which I'm not getting into this video, all right? But you can create what's called a storage account, and you can log data with both having the storage account as well as your log analytics workspace. You can have data that's going to be logged into that log analytics workspace, all right? And then from there, with the help of that log analytics workspace, I can go, let's go back over here to our resource groups. We'll click on Monitor VM Demo RG. We're going to go to the Log Analytics workspace. And what will happen is you will have in this Log Analytics workspace, you'll have this blade called Logs. I can click on that, and I can do queries for all of the logged data that I've gathered. All right, including with networking. Now, granted, again, I warned you that you have to link it first, and I showed you a minute ago that it can take about an hour before you can link it. But once you do that, you can start gathering all this. All right. So those are the things I want you to be thinking about when it comes to monitoring and troubleshooting network connectivity in Azure. All right. I no longer need any of these resources. We simply created these resources for this video. So I am going to delete my resource group. So we're going to go back over, we're going to click Overview, we're going to go right here to our resource group, which is Monitor VM Demo RG, and we're going to delete this resource group, which is going to delete all the resources in it, and that way we're not using any Azure credits anymore for these resources. So we're going to click Apply Force Deletion, we're going to click Delete, and that it'll take a few minutes, but it is going to delete those resources. All right? And so those are the things I wanted to go over. You're welcome to move on now. I'd now like to get into the concepts of Azure Virtual Desktop user data storage. Now, the main solution that Microsoft uses for dealing with the storage of user data in regards to Azure Virtual Desktop is a solution called FSLogix. All right, FSLogix is a feature that Microsoft has available to us to essentially provide what's known as a profile container. This profile container makes it where when a user logs on, their profile can be attached to them wherever they're at. So imagine you've got a Azure Virtual Desktop pool, what's called a host pool. So a group of virtual machines, this pool of virtual machine or instances of these virtual machines that a user can remote desktop into, and it doesn't matter which virtual machine is associated to the user, their profile data gets linked to that virtual session, and their data will be with them, whether they're attached to a specific virtual machine or a different virtual machine based on the Azure Virtual Desktop pool. Okay, so the idea is they sign in, the container gets dynamically attached to the computing environment, and it's going to use the standard format that we're all used to in regards to Microsoft virtualization, which is VHD or VHDX files. All right. This makes the user's data available almost immediately as soon as they connect. All right. The other thing that's nice about this is it also supports other Azure file types, not just profiles. Now, speaking of profiles, just to clarify, let's make sure we're familiar with this concept. Now, going as far back as the 1990s, we have had different profiles for users and different types of uses for profiles. Essentially, your user profile is the user state, essentially, that a user has when they log onto a machine. So when they log onto a Windows machine, they have a profile that's associated to them. Okay, now normally this profile would be what's called a local profile, where when they log on, their desktop environment, their documents, their music, videos, pictures, whatever it may be, are all stored in their profile folder, including this will also be associated with email and things like that. That's all associated with their user profile, or what's called user state. Now, back in the early days, Microsoft had a thing called roaming profiles, where you could store your profile on a server, and when you would go to log on to a Windows machine, it would connect to the server. Well, this is a similar concept, only it utilizes virtualization, and it utilizes a virtual hard drive. You can roam around, and your profile is going to go wherever you want. All right. And you also have what's known as a remote user profile, which uses a partition. Again, it's a virtual hard drive, and it allows the operating system even to be replaced or changed without affecting the user data. All right, so again, a user could actually switch from, say, Windows 10 to Windows 11, and their user profile data is going to be available. Doesn't matter which OS they're using. This can be helpful in scenarios where maybe you're needing to do an operating system upgrade, you're replacing an existing VM, or a user is being part of a pooled remote desktop session host or some type of VDI environment. They can jump around all they want, and their profile data is going to follow them wherever they go. Another thing about FSLogix, now this whole concept originally was a company. This was something that was acquired by Microsoft back in November of 2018, and this solution that they purchased was a better solution than what Microsoft offered. They had various options for handling the issue of profile data, but none of them were as good as FSLogix. All right. So this solution provides good performance, high performance. It resolves some of the issues of what's known as blocking cached exchange mode. OneDrive is supported. OneDrive for Business was not supported by the non-persistent remote desktop session host or VDI environments. The OneDrive VDI support is something that you're starting to have this capability to support. There's more information on that if you do a little searching. But anyway, with FSLogix, we now have some OneDrive support. You also have additional folders that's supported as well. So it's not just the standard profile folders that can be roaming with the user. Other folders can as well. So the other thing here, you have Azure Files integrations with Azure Active Directory Domain Services. With FSLogix, it used to be you absolutely could only utilize this technology with an on-premise domain, but it now supports the Azure Active Directory Domain Services as well. It doesn't just have to be on-premise domain. All right, and it's going to work in conjunction with full-blown cloud services, even without the use of an on-premise infrastructure. All right. They've also addressed some of the cost and administrative overhead associated with making some of that stuff work. Although, if you are going to use this in conjunction with the cloud version of ADDS, which is called Azure ADDS, this is going to be a premium solution that you can utilize. So you can utilize premium storage and all that for this, but not going to get too deep into that in this video. Best practices for Azure Virtual Desktop when it comes to all this. Some of the things to consider when you're going to deal with Azure Virtual Desktop storage. The storage account that's going to host storage for an Azure Virtual Desktop must be in the same region as the session host VM. So if you, for example, in my case, if I'm going to go East US for my session host virtual machines that people would connect into, then my storage account's got to be in East US as well. All right, same region. Another thing would be permissions. Your permissions need to match the permissions that are part of the requirements of profile containers. And I'm not going to get deep into that into this video, but essentially there are a few requirements there that you have to set up as far as permissions goes. Each host pool VM must be built of the same type and size VM as what's called the master image. Okay. which again, you're not real familiar with master images and all that, don't worry. That's coming up. All right. Each host pool VM must be in the same resource group to aid management, scaling, and updating. And then for optimal performance, your solution and the FSLogix profile container should be in the same data center location as well. And that's where you start learning about Azure region, where there's what's called zones, which are essentially representing the different data centers that are in an Azure region. Then the storage account container containing the master image must also be in the same region and subscription where the VMs are being provisioned. So those are also a couple other things to think about there. All right. Well, hopefully now you at least have a foundational understanding of the concept of what FSLogix is. In this video, I want to give you a better visualization of how this whole FSLogix system works in conjunction with our Azure virtual machines or Azure Virtual Desktop. So in the setup, let's kind of take inventory of what we've got here. The first thing to notice is we have our on-premise devices here. So we have some endpoints. You'll see the endpoints right here. These are machines that could connect in using remote desktop, whether they're HTML5, whether they're Windows, Mac, iOS, Android, Linux. Those are our endpoints. Okay. Now over here, obviously we have the Azure Cloud Services. That's this whole area over here. All right. And we got different ways that we could make a connection. Now, first off, I want you to understand that what you're seeing in this drawing is not the only way this could be accomplished, but in this drawing, they're using a VPN gateway right here, or ExpressRoute. Okay, so you could use a VPN gateway, or you can use ExpressRoute. In this case, there's an ExpressRoute connection. That means they've got a dedicated connection directly into Azure. But just so you know, you don't have to have that. You could do a VPN gateway, or you could just not have any of that and just use a straight internet connection. You used to have to do either VPN gateway or ExpressRoute. Now you can actually do this across the internet, okay, without having either of those. So these machines just have to have an internet connection. Now another thing that's going on is, in this case, they've got an on-premise ADDS server for authentication. Instead of just authenticating with Azure AD or Azure ADDS or any of that, they're using on-premise Active Directory, which is a pretty common setup, I would say. So you got on-premise Active Directory, so this is a domain controller, and they've got an Azure AD Connect server. What does that mean? Well, that means that in Azure AD, they are synchronizing all of their user accounts from the on-premise network to Azure Active Directory, or if they're not synchronizing all their users, they are synchronizing some of their user accounts into Azure Active Directory. That way, Azure Active Directory can authenticate with ADDS on-premise. Okay. Now, the next thing of note here is that right here you can see they have set up Azure Virtual Desktops, and because they're using a Virtual Desktops, Azure Virtual Desktops, these Virtual Desktops have what's called the control plane. And you can support web access. You have a gateway that's establishing the connection with your host pools and all that. You have broker for load balancing, and then of course diagnostics and all of that. And they've got REST API, which is representational state transfer, which means they can send stuff back and forth using HTTPS for encryption and ease of use using port 443. Anyway, they've set up 2 session host pools here. You can see a host pool A, and you've got host pool B. All right. And the key thing that we need to look at, because the point of this is to talk more about FSLogix, is that we have 3 storage accounts. All right. And these storage accounts could be used for various reasons. They haven't specifically labeled what they're using each storage account for. But essentially, with the storage account, we can have virtual hard drives that store all the profile data for each user who is connected. These VHD files can be associated with an Azure storage account. And the storage account is, of course, the storage infrastructure that Azure has available. All right? It's one of the main ways of providing storage. And so what you've got is you've got a VHD, you've got VHD files or VHDX files, either one. VHDX being the newer format, can hold more than 2 terabytes inside the storage account. All right, so what FSLogix is going to do for us is you're going to have a person who's authenticating, right? This person is going to, in this case, because you got ExpressRoute, they're going to be authenticating. The first thing that has to happen is they authenticate with ADDS. ADDS authenticates them in conjunction with Azure Active Directory. Azure Active Directory will provide what's known as a session token, which is just proof that the user has authenticated. So now that user session is established and they're able to go and communicate through this gateway, through this perimeter. In this case, they've got a perimeter network set up. All right. And when it comes to verifying authentication, you have in Azure, if you're using an Azure ADDS server like they're doing here, instead of here, it's going to work the same way. They're going to get a session token, what's called a session token, and that session token is proof that they have authenticated. All right. From there, they're going to go, the gateway is going to be passing them into whichever the session pool they're supposed to go to. It utilizing the Windows Virtual Desktop control plane here with the gateway and the broker and all that, it will link them to whichever storage account contains the Azure Virtual Hard Disk that will be used for their profile. So FSLogix is all the behind the scenes stuff that's making this possible. It's making it so that my virtual hard drive can be stored in this storage account. So this for users connecting in, this might be the VM they're connecting to right now, but it's going to link them to that VHD so their profile data will be available. The next time they connect in, it could be this virtual machine they go to. It's going to link them to their data. The next time they connect in, they get sent, they might be this virtual machine and they go here. Next time they connect in might be this one and they go here. So no matter what virtual machine they get linked to, no matter what session they're connecting to, they're going to get linked to the virtual hard drive that contains their profile data. All right. And this is what the FSLogix brings to the table. It brings the infrastructure, all the behind the scenes software that's needed to make that happen. Before FSLogix came out, before Microsoft acquired them, there really wasn't a good solution for dealing with that issue. There was solutions for that were available, but they weren't as good. They weren't as seamless. So FSLogix makes that a whole lot easier, a whole lot more transparent and seamless for your users connecting to their profile data. Now, if we're going to implement Azure Virtual Desktop and consider the user data storage side of things, the first step is going to be to create a storage account. The storage account, of course, is the main type of resource that we will need anytime you want to store information in Azure. So that's going to be our starting point. And right now, I'd like to walk you through creating a storage account. So here we are on portal.azure.com. Okay. If you click the menu button, you could go to all services and search for storage accounts. If you've got storage accounts blade showing up there, you can add that, but you can also search for it. If you're on all services, it may also show up right here. But I'm going to go ahead and click on storage accounts. You can see that I currently don't have a storage account. So I'm going to click to create a storage account. And we'll need a resource group. I've got a resource group called DemoRG, but I could always create a new resource group if I wanted to. I'm just going to use DemoRG as my resource group. And then I'm going to give the storage account a name. Now, let me warn you that when you are doing a storage account, if you're going to utilize FSLogix, it's going to tie to on-premise Active Directory, you need to stick to the 15-character rule. Because going back to all the NetBIOS-based standards from back in the day with Windows SMB shares, server message block shares, there are some restrictions on the character limit. So we're going to use a name that is no more than 15 characters in length. Secondly, you also need to consider that storage accounts are web-based right out of the gates. They have to be globally unique. That means there cannot be two people two Azure accounts in the world that have the same storage account name. So it's got to be a unique storage account. Okay. So in my case, I am going to call this ELP storage, and let's say we'll put AVD for Azure Virtual Desktop. All right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters. All right. And of course, if you're doing this, you need to make sure you use something unique, no more than 15 characters. This is going to be East US for me. And when it comes to working with FSLogix and using user data, you're going to have a high amount of IOPS, so you're going to want to go with a premium storage here. Okay. So that is definitely something to consider. As far as premium account type, I'm going to go with file shares. And then as far as redundancy goes, LRS is going to be fine for what we're using. Okay, we're not going to get into a lot of redundancy right now. And then from there, I would click Next. I don't have anything on Advanced that I need to do. I'm going to go to Networking. And then on Networking, it says Enable Public Access from all networks. Now, when you first hear that, immediately what people think is that this is going to be publicly just exposed to the world. But no, your storage account is locked down by default. There are security capabilities and features in place for allowing access, such as what are called SAS tokens. But I'm not going to get into that right now. Okay. So from there, I'm going to go ahead and click Next. As far as for file shares and all that, there's not really a lot of features here you have to worry about. There is a soft delete feature that can be enabled. That way, if you delete your data by accident, you can recover it right out of the gates for 7 days. That's what soft delete. I'm going to turn that off because I don't really need it for this lab environment. From there, I'm going to click Next. Not going to do anything with encryption right now. Not going to do anything with tags. I'm going to click Review and Create. And then I'm going to click Create. Okay, so we'll give that just a moment to finish. I'll pause my recording, and then we'll just verify that it's there. Okay, so that only takes about a minute, and then as you can see, it's done. Let's just go to the resource and verify that the storage account is there. All right, it is there. It's in East US. As you can see, we got premium performance, and if we click on file shares currently, we don't have any file shares. All right, so we've now set up our storage account, and that is the only thing I really wanted to get across to you in this little video. Now that we have a storage account set up, we're going to need a file share that we could use with FSLogix and all that if we want to be able to synchronize user data and go that route. Now, I am going to warn you that we are not setting up the full FSLogix and all that right now. We are just going to look at creating a file share. So just stay tuned here. But here we are on portal.azure.com. All right. We can do a search for storage accounts on all services, or just click on storage accounts right here. We have one storage account that I've already created, this ELP storage AVD. Remember, it's got to be a unique name. So we'll go into that and we'll click on file shares. All right. So at this point, we need to create a file share. Okay. And we would call this whatever we want to call it. I'm just going to call it a ELP user data. All right, and you can set the max capacity. Now, let me warn you that in the real world, you would need to consider the amount of data that will need to go in this. All right, and just so you know that as soon as you click Create, it is going to provision that amount of storage. All right, and at that point, Microsoft will start charging you based on what you provision. Okay. So they've set it here 1024 gigabyte. I'm going to set this to 100 just to keep it at the minimum, because that is going to be the minimum, and it is going to be the SMB protocol. And then we would click to create. All right, and just like that, we've now got our share. Okay, now something else that I'm not going to get into the details on right now is that we would want to set up our authentication with Active Directory. Okay, so we would click here to where it says not configured, and we would go through this process of setting up a connection with Active Directory. Again, not doing that right now. In fact, I wanted to show you how to create this share, but because it's going to charge us money and we don't actually need this share right now, I'm going to delete it. I wanted to show you real quick how to create it in this video. And creating the storage account, creating the share. I wanted to show you how to do that, but we don't need it right now. So I'm actually going to delete it. Okay. I know that sounds crazy, but just trust me on this. I could leave it and it would start using Azure credit, but since we don't really need it just yet, we can always go back and create it later. Okay. When we do need it, right? So I'm just going to delete it, but hopefully that does show you now how we can create a file share within our storage account. I'd now like to explain Azure NetApp Files. So what is Azure NetApp Files? This is Microsoft's enterprise class high performance storage solution, and it's going to provide you with a network attached storage based system that a lot of us are familiar with in our on-premise environments. So if you're familiar with that, setting up NAS equipment and all that, this is an extremely high performance cloud hosted service that you can utilize. Okay, it does support SMB, the server message block protocol, as well as the NFS protocol, network file system, which you might be familiar with Linux, Unix, Macintosh based systems. And it provides extreme amount of data protection and disaster recovery. The other thing, of course, is high performance. You'll get an extremely high amount of throughput with this system. It can utilize lots of high amounts of random read and write operations, high concurrency, and extremely fast network speeds. So Microsoft has dedicated equipment for this, whereas when you're using just a standard storage account, you can get extremely high performance, but this has dedicated equipment for it. So it's very, very low latency. It uses all flash bare metal equipment. In fact, a whole fleet of equipment. It supports the standard protocols, like I said, SMB, NFS v3, NFS v4.1, dual protocol volumes. It's very, very scalable. You can scale up and scale down at any time. Increase and decrease the size of volumes you want. Also, you get the ability of changing of service levels, so you can have you can basically dynamically and online change your volume service levels to set your capacity to what you want it to be and your performance to what you want it to be. In other words, it's very, very flexible as far as changing and reconfiguring speeds and latencies and all of that. It's very optimized for certain types of workloads that you might be using it for. So depending upon what you're using it for, you can kind of fine tune it for that capability you're looking for. The other thing is extreme high availability. You have automatic failover capabilities with this. So since it is, it's hosted on a certain equipment, it automatically does synchronous replication of data, and so you get a very fast automatic failover system. It supports multi-protocol, supports self-healing. In other words, if it's detecting there is some latency problems with some of the equipment, it'll go ahead and fail over to another one, to other equipment. You have availability zones with it as well. So if you aren't already aware, in most regions of Azure, there are 3 different data centers, or what we call 3 different zones. You can have a copy of your data in the multiple zones or multiple data centers. So if an entire data center goes down, you've got multiple copies of your data out there. All right. Another thing is with the data replication, they provide a high amount of service level agreement. You actually get a 4.9 based service level agreement. So you'll have little to no downtime there. And also you have data protection. So you get snapshot copies, your point-in-time snapshots of your volumes, so you can go back in time on data if need be, backups and restores. You get data replication, and also Microsoft is providing state-of-the-art security for everything, as well as authentication, where when you are interacting with your data, every device or user that's interacting with it must go through the authentication process. Okay. So this is definitely something to consider in bigger environments. It's not something that we focus a great deal on in this course. It is something you can learn more about, though, and consider, especially for larger environments that need even more performance than what you would get with your standard storage account.
Hey, this is John Christopher. I hope you enjoyed getting to experience a little bit of this course, and I hope you'll join me on the full adventure. If you'll check the description of this video, you'll see a link that'll show you how you can get access to the full course. Now, in the full course, you're going to learn how to set up a practice environment where you can practice hands-on, and I'm going to provide you with lots of virtual simulations that you can do 24/7. All you need is a web browser. So I hope you'll join me, and I hope you'll also give me a like and subscribe. I'm trying very, very hard to get this channel to build and grow, and so I hope you'll take the time to do that.